No. I can solve and graph multi-step one variable equations. Read together. 1, 2, 3. I can solve and graph multi-step one variable equations. So you never what the concept for today is. What's the concept? That is correct. One variable equations. One variable equations. One variable equation. One variable equation. I'm hypnotizing you. So yeah, we're still on one variable equations. All right? We don't need a fair model because we already know the definition, yes? Do we know the steps? What are the 4 steps? Simplify, isolate, plot, check. Our properties also, we already know them. Then we got to some practice problems like this one, yes? Like this. We got some of these. Some of these for home play. We got to the Jordan problem, yes? And then we got to the variables on both sides. Then we got to this one. And lastly, I gave you guys this one. Is that correct? Okay. So write this down. Example 13, please. Whoop. Copy that, please. And solve it by yourself. See what you get. And then I'll go back and go over it with you. Go. Oh, I forgot. Sorry. Let me get you started. There you go. There it is. All right, here we go. I'm going to work the first step. First step was to combine one of the sides. I'm going to combine this side. This becomes negative 2a. And I'm going to bring down the plus 4. Some of you wrote 4 minus 2a. Is that correct? I'm going to try and keep it so that I write it in standard form every time. Next, I'm going to distribute here. This becomes negative 1 minus 35 plus 10a. But if I need to combine this and write it in standard form, which one goes first? 10a minus 36. Are we there so far? All right. Can I simplify the left side anymore? No. The right side anymore? No. What's my smallest variable? Negative 2a. What is the opposite of that? Positive 2a. Whatever we do to one side, we do to the other. We're left with 4 equals 12a minus 36. Are we there so far? From there, I go to negative 36. What is the inverse? Positive 36, positive 36. We're left with 40 equals 12a. And what's our last step? Divide by 12. Divide by 12. 12 fits in there 3 times, and we're left with 4 12s equals a. Can I simplify that? Yes, this is 3 1/3 equals a. And if you got that. Okay, good. Yes? Okay, so we need to get rid of this variable here, right, on this side. What cancels a negative 2a? We do the inverse, yes? All right, yes? All right, so why did I write this like this? Guys, focus. Why did I write this instead of writing it like that, like this? Because I want it in what? Standard form. Every step of the way. Try and write and get used to your noodle writing in standard form. Copy this next one, please. Example 14. Yes, let me zoom in again. Oh, sorry. Copy that. We're going to do this one together. Okay? All right, here we go. Line down the equal sign. For the left side, we can combine like terms, yes? We can combine 10 and 1, can't we? But I'm going to bring down the variable first so we can keep it in standard form. So I'm going to write negative 5x What is 10 plus 1? That's 11. I'm done with the left side. Go to the right side. Can I combine anything on the right side? Yes, the 7 and the negative 12. What does that give me? Negative 5x, and I bring down the 11. Before I continue, let's see. What do you guys notice about the left and the right side? Everyone. They're the same. Okay? So check this out. I'll come back to that, but for right now, think about it. They are the same. Let's continue. What would be our next step? Get rid of the variable. Is that correct? So what would be the next step? Add 5x. Add 5x. However, look. This cancels and this cancels, and we're left with 11 equals 11. Okay? Something happened, but at the end, we get 11 equals 11. Is 11 equal 11? Yes. So that means we're still good up to right there because we still have a good balanced equation. Is that correct? Because we're thinking about it as a scale. Remember the scale? It's still balanced. However, let me go back to this one. Pay attention, please. We said that this looks the same as this. What's another word for the same? Equal. What's another name for equal? This one is what to this one? Yeah, what's another? What was it, Daniel? Identical. That's why we call this an identity. Write this down, please. Identity. Because they are identical. Now check this out. We started the school year with our number line. Now this has a purpose. Pay attention, please. Look up. If I was to substitute 0 in here, what is negative 5 times 0? Plus 11? 11. What would we get on this side? The same, because it's a what? Identity. Okay. Let's say I picked a number from this side, a positive number. Doesn't matter which one, but for right now, I'm going to pick 1. What is negative 5 times 1? Negative 5 plus 11? 6. What would we get on this side? The same, because they are what? Identical, or an identity. And does it still work? What would you get? 6 equal to 6? Yes, it's true. What if I substituted a negative number? Doesn't matter which one. What would I get on this side? The same as the other side, because it's a what? Identity. Therefore, think about this question. If that's true and I continue doing that, and I keep getting the same answer for both sides, tell your neighbor what would be the solution to this equation. Talk it over, please. Aaron, go. Yes. A number on the what? On the negative line? Only the negative number? The positive 2? So what would be what would you say the solution would be? X equals what? X equals 1. Is that the only solution? No. Let's see. Gavin. Boom. Any number on the real number line. That is correct. That's a symbol for real numbers. Yes. That's infinity, yes. No, because infinity is over here. I know, but there's also a negative infinity. Okay, so let's see if we get this. Focus, please. So does everybody understand why the solution to this equation is all real numbers? Because I can substitute all positives, and we're going to get the same thing on both sides. I can substitute negatives, we get the same thing on both sides. And if I substitute 0, we get 11 equals 11. Does that make sense? All right, copy this next one, please. Example 15. Oh, my goodness. Copy that. All right, let's see. Let me help you out with this one. There you go. Woo, let's go. Enrique, help me with the left side. What do I do? Combine like terms. So tell me what to write. Hands if you got that. Okay, so far so good. On the right side, is I? Hands if you got that. So far so good. And of course the next step would be what, everyone? Negative 13x, negative 13x. And these cancel. What do we have left? Negative 3 equals negative 4. Question, is negative 3 equal to negative 4? Whenever you get to these, pay attention please, and that is not true, it's an error. You do this. You cross out the equal sign because they're not equal. Is that correct? So talk it over to your neighbor, let them know what's going to happen if we have a number not equal to this other number. Let's see. Leslie, what would be the solution to this equation? Check this out. If I was to continue substituting values for x here, wouldn't the same value go here? And whatever that is, we're going to end up with a number not equal to another number all the way through. So what would be the solution or the answer to this equation? Gavin? No solution. Once again, if I was to substitute 0 for x, what is 0 times 13? And I end up with negative 3, and over here 0 minus 4 is negative 4. Is this true? No. If I was to substitute 1 in here, 13 minus 3 is 10, 13 minus 4 is 9. Is 10 equal to 9? No. And so on and so forth. That's why there is no solution. So now, talk it over to your neighbor, let them know. Can you tell from here when there's not going to be a solution? Talk it over to your neighbor, please. All right. We can't tell from there, right? We can't tell. Check this out. The difference from this one to this one is that this one, they're identical, and this one, only the variables are identical. Everybody with me? That's how we can tell that there's not going to be a solution when the constants are different. Now check this out. If our, let's see, who's absent today? Haley, who else? I know, but she's absent from class. And listen, let's say they come in tomorrow and say, what did we do, Mr. Q? Oh, we went over the first problem just to practice, and we got A equals 3 1/3. Then we covered one of these that have what? All real numbers for solution. And we covered one of these with no solution. But at the end, we can conclude that when we solve multi-step equations, there's only three options? Talk it over with your neighbor. What are the three options for a solution? All right. Justin, summarize it for us. What are the three only options for multi-step equations? No solution, identity or all real numbers, and one solution. Everybody agree with that? All right. Lastly, check this out. Yesterday we covered a Jordan problem. Remember that? How many people were there? 3. So we drew 3 lines down and so on and so forth. Remember that? Look at this next one. It says, Luca sold 4 more shirts than Cooper. Joanne sold 3 times as many shirts as Luca. In total, all 3 sold 51 shirts. How many shirts did Joanne sell? How many lines down for this table? 3 lines. How many lines down for this table? 3. And it's very similar to the one we just did, right? Let me show you one that is not similar to these. Here we go. It says, a construction company charges $4.50 plus $28 per hour. Another construction company charges $4.10 plus $32 per hour. How long will it take for us for the job for the 2 companies to cost the same? So let's do this one together on your paper, right? Example super Q, you're not going to copy this. We're going to start from the table, okay? So, Andrew, how many items or how many people or how many items are they talking about? How many? 2. That is correct. 2 construction companies. So how many lines down? 2. 1, 2, and 1 across. Do they give us the name for the first company? What can we label it? Very good. A. What can we label the second one? B. And at the end we're going to write total. All right. So let's write for the first company. Let's see. How much do they charge from the very beginning? So we're going to put plus $4.50. How much do they charge per hour? And do we know how many hours? No. So we will write what? 28x. That is correct. I want you to write me the expression for the second company. And here's the information. Write the expression for the second company. Skylar, go. 32x plus 410. Hands if you got that. Okay, now in the total, look what we're going to write, because it says here, how long is a job for when the 2 companies cost the same? What's another word for the same? When they are what? Identical. Not identical, but when they are equal. So that means this company equal to that company. Does everyone understand? Company A when it's equal to company B. So what am I going to write for company A? 28x plus 450 equal to what? 32x plus 410. Do we know what to do from there? All right, finish it off, please. So like that we can find out how many hours it's going to cost for them to cost the same. And I'll call on someone. If they get it, we're done. If not, we do one more. Okay, Andrew, help me from there. What do I do? Subtract 28x, subtract 28x. That is correct. We get 450 equals 4x plus 410. Continue, Enrique. subtract the 410 from each side. We're left with 40 equals 4x. And lastly, Daniel B. Divide both sides by 4. Are we done? No. The question was, how long is the job for when the two companies' costs are the same? Who can give me a statement? Abraham. The job for the two companies to cost the same are what? 10 hours. Andrew, you got that? That is correct. Home plate tonight is on page 95 only. Good one, guys. Enjoy your home plate. There is tutoring. If I don't see you guys, always. Bye.